To truly understand why this matters, you first need to understand where BYD stands today. Because this is not a small startup making bold promises. This is a company that has already reshaped the global electric vehicle market in ways that very few people predicted even 5 years ago. Just a few years ago, BYD was largely dismissed outside of China. Many people saw it as just another Chinese car brand trying to compete in a crowded space. But then the numbers started telling a very different story. In 2023 alone, BYD sold more than 3 million electric and plug-in hybrid vehicles. That number stunned analysts who had underestimated the company's production capacity and market appeal. By 2024, the growth accelerated even further. BYD was not just growing fast, it was growing faster than almost anyone in the industry had projected. The company was not relying on one popular model or one lucky market. It was expanding across Asia, Europe, Latin America, and the Middle East with a broad lineup of vehicles at multiple price points. But raw sales numbers only tell part of the story. What truly separates BYD from most of its competitors is something that goes much deeper than showroom figures. BYD manufactures its own batteries, its own motors, its own power electronics, and many of its own critical components. This is called vertical integration, and in the automobile industry, it is an enormous strategic advantage. Most car companies rely on a complex web of suppliers. They buy batteries from one company, motors from another, and electronic systems from several others. This creates cost pressure, supply chain risk, and limits how tightly different components can be optimized together. BYD largely eliminated that problem by bringing everything under one roof. This vertical integration is also the reason BYD was able to develop its Blade battery technology, which received worldwide attention for being safer, more stable, and longer lasting than many conventional electric vehicle batteries. The Blade battery is designed differently. Its cells are long and thin, arranged flat across the floor of the vehicle. This layout lowers the car's center of gravity, improves stability, and creates more usable interior space. But what really makes it valuable is how it manages heat. Heat is one of the biggest enemies of battery performance. The Blade battery's design allows heat to spread and dissipate more naturally, keeping the battery stable even under demanding conditions. And now BYD has taken that same philosophy of smart engineering and applied it to something new, the motor. And this is where things get genuinely exciting for anyone following the future of electric vehicles. The technology at the center of all this attention is called the Hairpin motor. It is part of BYD's broader 8-in-1 electric powertrain platform, a system that integrates the motor, inverter, controller, charger, and several other critical components into one compact and highly efficient unit. This is not simply a marketing label. The integration of all these components into a single system has real engineering consequences. It reduces weight, saves space, simplifies manufacturing, and allows each component to communicate and coordinate with the others far more precisely than if they were built separately by different manufacturers. The Hairpin motor itself gets its name from the distinctive shape of its internal copper winding. In a traditional electric motor, copper wire is wound in rounded circular coils inside the motor's stator. This is a perfectly functional method, but it has limits when it comes to how tightly the copper can be packed and how efficiently electricity can flow through it. The Hairpin motor takes a fundamentally different approach. The copper is formed into precise U-shaped conductors that look like hairpins. These are inserted into the stator slots with far greater density and precision than traditional wire winding allows. The result of this design change is significant. More copper fits into the same space. The electrical resistance is lower. The flow of electricity through the motor is more efficient and more consistent. In practical terms, this means the motor can generate more power while consuming less energy to do it. That is the core promise of the Hairpin motor, and BYD claims to have achieved an efficiency rating of around 97% with this technology. To put that number in context, most electric motors operate somewhere between 90 and 95% efficiency. Getting to 97% is not a small incremental improvement. It represents a meaningful step forward in how much of the stored battery energy actually reaches the wheels. Performance figures back up these claims. Several of BYD's high-performance electric vehicles equipped with this motor technology can accelerate from 0 to 100 kilometers per hour in approximately 3 to 4 seconds. That is a level of acceleration that competes directly with petrol-powered sports cars that cost significantly more. The motor can also spin at around 16,000 RPM, which is a strong figure for an electric motor, and contributes to the smooth, continuous delivery of power that drivers experience when they press the accelerator. But there is something even more important than the peak performance numbers. It is what happens over time and under real-world driving conditions. One of the most persistent challenges in electric motor engineering is heat management. When a motor generates heat and cannot get rid of it effectively, performance begins to degrade. Efficiency drops, power output decreases, the driving experience suffers. BYD engineers designed the Hairpin motor with a dedicated cooling system that addresses this problem directly. The motor can sustain its performance over longer periods without heat-related degradation. This is not just good for the driving experience, it is good for the long-term reliability and durability of the vehicle. Now here's where the story becomes particularly compelling. The Hairpin motor does not exist in isolation inside a BYD vehicle. It works in close coordination with the Blade battery. And understanding that relationship is key to understanding why the combination is being taken so seriously by competitors and analysts alike. When you press the accelerator in an electric car, the battery must deliver electricity to the motor quickly, smoothly, and consistently. If there are fluctuations or delays in that delivery, the motor cannot perform at its best. The Blade battery was designed to deliver power in an exceptionally stable and controlled manner. There are no sudden drops or spikes in the electricity supply. The current flows steadily and reliably from battery to motor. This consistent power delivery allows the Hairpin motor to operate in its optimal range continuously, producing smoother acceleration and better overall responsiveness. The coordination between these two systems also has a direct impact on driving range. Every time energy is converted or transferred inefficiently, some of it is lost as heat. The Hairpin motor's high efficiency means less energy is wasted in conversion. The Blade battery's stable discharge means less energy is lost in delivery. Together, they create a system where a higher proportion of the stored energy actually moves the vehicle forward. The practical result is that BYD vehicles using this combination tend to achieve strong driving ranges relative to their battery size, which in turn supports the company's ability to price vehicles competitively.
There is also a structural benefit from the Blade battery's floor-mounted design that directly complements the motor's performance characteristics. Because the battery sits low in the vehicle, the center of gravity is closer to the road surface. This makes the vehicle more stable during cornering and at higher speeds. When the motor delivers power smoothly and the chassis is planted and stable, the overall driving dynamic improves significantly. It creates a driving experience that feels composed and confident rather than abrupt or unpredictable. Because BYD designs and manufactures both systems internally, the engineers working on the battery and the engineers working on the motor are working toward the same goals with the same data. They can optimize the interaction between the two systems at a level of detail that companies relying on external suppliers simply cannot match. This is the quiet but powerful advantage that vertical integration gives BYD, and it shows up not just in cost savings, but in the coherence and performance of the final product. Now let us look at what all of this means for the broader competitive landscape, because the implications extend well beyond BYD itself. They touch every major name in the electric vehicle industry. Tesla has long been the benchmark for electric vehicle performance and technology. Elon Musk's company did something remarkable in the early years of the EV revolution. It proved that electric cars could be genuinely exciting. They could be fast, stylish, technologically impressive, and desirable in ways that went beyond environmental appeal. Tesla built a brand, a community, and a technology ecosystem that gave it a substantial lead over traditional automakers who were slow to take electric vehicles seriously. That lead has been real and meaningful, but it has also been narrowing. The challenge Tesla faces from BYD is not simply about one new motor or one new battery design. It is about the cumulative effect of a company that is competing aggressively across multiple dimensions simultaneously. BYD is offering comparable technology at lower prices, producing vehicles at massive scale, expanding into international markets rapidly, and continuing to develop new innovations from within its vertically integrated manufacturing structure. If BYD's Hairpin motor and Blade battery combination delivers on its promises at scale, it gives buyers in many markets a compelling reason to choose BYD over Tesla without having to compromise on performance. Toyota's situation is different but equally complicated. For years, Toyota resisted the rapid shift toward fully electric vehicles, placing its strategic bets on hybrid technology and eventually hydrogen fuel cells. There is logic in that position. Toyota's hybrid vehicles, particularly those in the Prius family, have been engineering and commercial successes.
But the pace at which companies like BYD are advancing pure electric technology is forcing a strategic reckoning. If the market moves decisively toward battery electric vehicles faster than Toyota's current roadmap anticipates, the company could find itself in a difficult position with limited competitive products in the segments that matter most. For major European manufacturers like Volkswagen, BMW, and Mercedes, the challenge has a specific economic dimension. Manufacturing costs in Europe are significantly higher than in China. Labor, energy, regulatory compliance, and infrastructure all contribute to a cost base that makes it structurally harder for European brands to compete on price with Chinese manufacturers. BYD benefits from large-scale, highly efficient production in China, and as it builds new factories in Thailand, Brazil, and Hungary, it will be able to manufacture vehicles locally in key markets, reducing logistics costs and potentially avoiding import tariffs. The competitive pressure on European brands is not simply about technology. It is about whether their cost structures can remain viable against a competitor that can offer advanced technology at substantially lower prices.
The cost advantage BYD holds is not accidental, and it is not simply a result of cheaper labor. It is a structural outcome of deliberate strategic choices made years ago. The decision to build its own battery manufacturing capability early, when others were still sourcing externally, paid off enormously as battery costs became one of the most important variables in electric vehicle economics. The decision to develop proprietary motor technology, rather than licensing or purchasing motors from suppliers, gives BYD control over a critical component that most other automakers still depend on external partners to provide. The 8-in-1 powertrain integration reduces part count, simplifies assembly, and lowers manufacturing complexity. Each of these decisions compounds over time into a cost structure that is genuinely difficult for competitors to replicate quickly. Large-scale production amplifies these advantages further. When a factory produces vehicles in the millions rather than the hundreds of thousands, fixed costs get distributed across more units, and manufacturing processes become more refined and efficient through repetition. BYD's factories in China are among the highest volume vehicle production facilities in the world. Every improvement in efficiency at that scale translates into meaningful cost reductions per vehicle. That is how BYD is able to launch electric cars at price points that repeatedly surprise international markets and force competitors to reconsider their own pricing strategies.
Looking ahead, BYD's plans make it clear that what we are seeing now is not a peak, it is a foundation. The company intends to deploy its advanced motor and battery technology across a much wider range of models in the coming years. Popular vehicles in the BYD lineup, including the Seal, Dolphin, Atto 3, and others, are already built on the company's advanced electric platform. Future models will extend these technologies further, bringing high efficiency and strong performance to more price segments and more markets. As this happens, the gap between what BYD offers and what competitors at similar price points can offer is likely to widen rather than narrow. The international manufacturing expansion adds another dimension to BYD's long-term strategy. Building factories in different regions is not just about reducing shipping costs, it is about becoming a local player in markets that matter. When a company manufactures vehicles within a country, it creates jobs, builds supplier relationships, and develops political goodwill that makes it harder for governments to restrict its market access through tariffs or regulations. BYD is positioning itself not as a Chinese exporter competing in foreign markets, but as a global manufacturer with local presence. That repositioning, if successful, will change how regulators, dealers, and consumers perceive and engage with the brand. What makes this entire story so fascinating is that the electric vehicle industry is still in a relatively early stage of its development. The technologies that define the market today are not necessarily the ones that will define it a decade from now. Solid-state batteries, new motor architectures, advanced power electronics, and vehicle software platforms are all areas of active development across multiple companies. The pace of innovation is high, and the competitive dynamics are shifting faster than most traditional automotive cycles allow for. In that environment, the companies that have invested most deeply in foundational technology and manufacturing capability have the greatest ability to absorb new developments and bring them to market at scale. BYD's Hairpin motor story is ultimately not just a story about one component. It is a story about what happens when a company builds its capabilities patiently and comprehensively over many years, resists the temptation to depend on external suppliers for its most critical technologies, and then finds itself at a moment when all of those investments converge into a product and price combination that the market finds genuinely compelling. That is a powerful position to be in, and the rest of the industry is watching very carefully, because the next chapter of the electric vehicle race is being written right now, and the outcome is far from decided. The battle for the future of electric cars is no longer a two-player game. It never really was, but now, more than ever, every company in the race needs to be paying attention to what BYD does next. The electric car race is heating up, and one company just quietly changed everything forever. For years, the global automobile industry has been locked in a fierce and unforgiving competition. Every major company was racing to build better batteries, longer ranges, and faster charging networks. Tesla was leading the charge. Toyota was holding its ground with hybrids. Volkswagen, BMW, and Mercedes were pouring billions into their electric futures. Everyone seemed focused on the same battlefield. But while the world was watching those visible fights, something else was happening quietly. A Chinese company was working in the background, developing a technology so significant that when it finally emerged, even seasoned industry experts had to stop and take notice. That company is BYD. And what it has just revealed about its new electric motor technology is the kind of development that does not just make headlines, it changes the direction of an entire industry. What makes this moment so different is the way it happened. BYD did not announce this with loud marketing campaigns or dramatic press conferences. The technology simply started emerging through reports, technical documents, and industry observations. And the more people looked at it, the more they realized something important was happening. This was not just a better motor. This was a rethinking of how electric vehicles are built from the inside out. The question now on everyone's mind is simple but powerful. Could this be the technology that finally shakes Tesla, Toyota, and every other major player in the electric car world?